Hello guys, welcome back to our SAS Certified Specialist Prep Guide, Base Programming using SAS 9.4. So we're still in Chapter 2, but we are on the final agenda, which is the SAS Datasets. Yeah, I had a very busy week last week, so I wasn't able to record video. Yeah, am I recording? Yeah, I'm recording. So here we'll discuss SAS datasets and the chapter quiz afterwards. I leave it to you guys. So yeah. So let's start. So overview of SAS dataset. A SAS dataset is a file that consists of two parts, a descriptor portion and data portion. So I think this is one of the lessons that you can be very sure that will be useful in your future, because understanding this will help you understand the processing of your programs, for example. So yeah, let's continue. Sometimes a SAS dataset also points to one or more indices, which enables us to locate rows in the dataset more efficiently. So aside from the descriptor portion and data portion, we also have the index portion of the dataset. And lastly, extended attributes are user-defined attributes that further defines a dataset. So I will not dig deep into this. I suggest you look into the documentation, but extended attributes usually means that metadata that is defined by you. So it's not part of the normal descriptor portion of the SAS dataset. You need to define this explicitly. Okay? So for example, here is the parts of SAS dataset. So the descriptor portion, so it contains the dataset properties, for example, the length of a variable, label, format, for example. We'll talk about that in the succeeding lessons. And the variable properties. Yeah, so for example, specific variable, what's its length? Yeah, a format, in format. So I think I switched that. The dataset properties more or less contains the size, file size, for example, the date of creation, and stuff like that. Then for the data portion, we had two components, the observations and the variable. So the variables is more or less like the column equivalent in an Excel spreadsheet, and observations are the row equivalent. So it contains the data for the specific variable. So we also had indexes. So this is more or less like a separate SAS file, but it helps to locate data, or rather retrieve data in more like direct way rather than sequentially accessing the data. So I think we will discuss this as well in the future chapters. And lastly, extended attributes. So again, this is more or less metadata defined by you. So moving on, the descriptor portion. The descriptor portion of a SAS dataset contains information about the dataset, including the following: the name of the dataset, the date and time that the dataset was created, the number of observations, and the number of variables. So here is an example of a descriptor portion. So here's the dataset name. So it's cert.ensure. It's on the permanent library cert. The dataset name is ensure. So member type, it's data. So we had other types as well. We'll discuss that in the future lessons. Engine v9. So this means that the dataset is created using the SAS v9 engine. So the time the dataset was created. So the observations 21, variable 7. So it's columns and rows. Indexes, so no index was created. Observation length 64. So this is the length from the first variable up to the last variable, the data length. So that's one observation length. So SAS at variable attributes. The descriptor portion of a SAS dataset contains information about the properties of each variable in the dataset. So the properties are the name of the variable, type, length, format, in format, and label. When you write SAS program, it is important to understand the attributes of the variables that you use. Yeah, so for example, you might need to combine SAS datasets that contain same name variable. Yeah, so in this case, the variables must be the same type, character, or numeric. So let me expand on this a bit. So for example, you have two tables you want to combine. Let's say to get the patient's bill from the patient's list, and when you combine that, for example, use the patient's name. So they must be both of the same type, let's say character, so that you don't have issues when combining them. Yeah, so if the same name variables are both character variables, you still need to check that the variable lengths are the same, otherwise some values might be truncated. Yeah, so this one, for example, you had primary dataset which has 10 characters of length, and you have the uh, mm, lookup dataset with 8 variables. So when you combine those two tables using that key but different length, you might get truncated data. So for example, the contents of the lookup table um, exceeds 8, for example 9, and then you combine that to the master data. So you expect to have a match of data, but you would not get one. So it's very great to ensure that the length of the same name variables are the same as well. So the following tables use cert that ensure data and the valid var name equals any system option. The SAS variables has several attributes that are listed here. So name, the variable attribute name identifies a variable. A variable name must conform to SAS naming rules. So this one we had discussed the valid var names. So here's the example columns: policy, total name, and any valid SAS name. So I guess we should try to look that in the on-demand academic site. It says the cert that ensure dataset. Yeah, so let's try to log in first. So the cert that ensure name has these variable names: policy, total, and name. Yeah, so while waiting for that one, let's move on to the next type. So identifies a variable as numeric or character. Character variables can contain any uh, values. Numeric variables can contain only numeric values. The numerals 0 through 9, plus minus, dot, and e for scientific notation. So the possible values are numeric and character. Length refers to the number of bytes used to store each of the variable's values in a SAS dataset. So character variables can be up to 32k bytes long. All numeric variables have a default length of 8 bytes. Numeric values are stored as floating point numbers in 8 bytes of storage. So for characters, we had limit of to 32k bytes, and for numeric, we have 8. So even the number is millions or billions, the default maximum value is 8. So it starts as floating point numbers and compressed in the 8 byte storage. So yeah, here we are. So let's try to check the cert that ensure dataset. So we get check the properties. No, not the properties. Yeah, so here's the variable names: ID, name, policy, company, percent insured, and when we click 1, here's the attributes. So length is 4, type is character, no formats, and in format. Yeah. So next, format affects how values are written. Formats do not change the stored value in any way, they merely control how that value is displayed. SAS offers a variety of character, numeric, and datetime formats. So the possible values are any SAS formats. If no format is specified, the default format is best12 dot for a numeric variable and $w dot for a character variable. So we'll discuss this later in the future lessons. But for now, for example, a number 98.64 that has a dollar format applied will be displayed as $98.64. So maybe we had some data here. Yeah, no, this doesn't have format applied. But if there's a format applied, the displayed value will be $98.64. Okay. In format. So in format reads data values in certain forms in standard SAS values. In formats determine how data values are read into SAS dataset. You must use in formats to read numeric values that contain letters or other special characters. So sample is 99. Any SAS in format, and the default in format for numeric is w.d, and for character is $double dot. So what this essentially say is that when you, for example, read a value in a file in a SAS dataset or text file that contains, for example, this value. So remember that we had only character and numeric data types, right? In here, the type. So you need to use in format so SAS can interpret this as a number. Yeah, so when SAS applies the in format to this one, it will detect, this is 98.64. So it helps us understand how to read the data values. Yeah, and last is label. So refers to a descriptive label up to 256 characters long. A variable label which can be printed by some SAS procedures is useful in writing. So for example, we had column policy. Yeah, and we want to have a much more descriptive description of the column. We can add a label. So this label can be, for example, policy for the patients, for example, something like that, so that when users report what policy, so at least we had a much more specific description of the variable. So the following output is the descriptor portion of cert that ensure. Yeah, so here we had 7 variables. We had 3 numeric type and 4 character types. This is the lengths. They vary, but notice the numeric variable has a maximum length of 8. So the balance, due, and total has $8.2 format and has a comma 10 dot in format. So it reads data, or it can read data that has comma and convert that into a dollar. So for example, it's 10,000, then it will add the dollar sign in the total value. And then label. So name, it's very generic. We can add patient name to give it a much more specific description. Policy number, and total means it's the total balance for the insured. Yeah. Okay, so moving on, data portion. So data portion of a SAS dataset is a collection of data values that are arranged in a rectangular table. In the example below, the company mutuality is a data value. Policy 32668 is a data value, and so on. So Yeah, so this is the data, the columns, and the rows. So observations, or also called rows, in the data are collections of data values that usually relate to single object. The values 24858, Murray, 32668, mutuality 100, 98.64, and 00 are comprised in a single observation in the dataset below. So yeah, this one whole line is an observation. So this dataset has 21 observations, each containing information about an individual. To view the full descriptor portion of this data, see table 2.3. So this is one's earlier. Yeah, this one, this descriptor portion of the table. Yeah, so essentially, observation is this full row of data. So the variables in the dataset are a collection of values that describe a particular characteristic. The values 2458, 2462, 2501, and 2523 are comprised in the variable ID in the dataset shown below. So we have the ID variable, and it comprises of these values. This dataset contains 7 variables: ID, name, policy, company, percent insured, total, and balance due. So a SAS dataset can store thousands of variables. Yeah, thousands of variables. I can attest to that. Even 10,000s of variables. Missing values. So every variable and observation in a SAS dataset must have a value. If a data value is unknown for a particular observation, a missing value is recorded in the SAS dataset. A period is the default value for missing numeric value, and a blank space is the default value for a missing character value. Yeah, so to represent missing values, we use the period or the dot, and for character missing values, we use blank space. Yeah. So here's an example. The percent insured of uh, Bonaventure T is missing. Yeah, so remember that. Yeah, so it's very much straightforward. So the variables are the columns, the observations are the rows of data. So we had 7 variables here, and the observation is this row one, this one. It's a combination of the column and rows. That's our data portion. And finally, the SAS Indexes. An index is a separate file that you can create for a SAS data file in order to provide direct access to a specific observation. So the index file has the same name as its data file and a member type of index. Yeah, so an index has a member type of index. Indices can provide faster access to specific observations, particularly when you have a large dataset. The purpose of SAS indices is to optimize word expressions and to facilitate by-group processing. So for more information, we will discuss that, yeah, in our future lessons. But essentially, an index is a file that can be used to retrieve information from a specific observation. So when we create an index for a dataset, for example, for ID, so we create a separate file aside from the dataset. So this index file is used to access faster the specific observations in the dataset. So it's pretty useful, especially if you perform um, lookups or word expressions or by group processing. So again, we will discuss this in future lessons. And last is extended attributes. So this is the last part of the dataset. So I mean, the composition of a dataset. So far we discussed the descriptor portion, the data portion, the SAS indices. So last is the extended attributes. Extended attributes are user-defined metadata that is defined for a dataset or for a variable column. So extended attributes are represented as name, value pair. So personally, I have not yet encountered any usage of this. So I leave it to you to check this one out. But essentially, you can use the uh, XATTR procedure to generate these extended attributes. This creates a separate file as well. So with a different file extension. Yeah, and essentially you tag a certain variable or dataset with this attribute. Yeah, so that's it for our current lesson. Yeah, again, I leave the chapter quiz guys to you. The guide has uh, answer keys as well at the end, so I suggest you answer first the chapter quiz, and then once you completed, these are like 10 questions only. Once you complete that, you check back the answer in the answer key section of the slide, or I mean the ebook, and then get back to what observations I'm sorry, on what items you had gotten right and you had gotten wrong, and get back to the items what you had gotten wrong, and take a quick note of what you had possibly missed. So yeah, that's it. So thanks for watching. On the next lesson, we will talk about accessing our data. So we had the SAS libraries and viewing SAS libraries. So again, thanks for watching and see you on the next video. Bye.